Today we are going to discuss some examples for checking the serializability of schedules. Here we have three transactions T1, T2 and T3. Here T1, this transaction T1 is having a read 1 of x, R1 of z and W1 of y. That means it is reading the variable x, reading the variable z and writing the variable x. Here this is T2 and this is reading z, reading by, writing z, writing by. And for T3 you have reading x, reading by and writing y. That means if you are executing this in a serial fashion, you can have T1, after that T1 you can have T2, then after T3. Okay, that is a serial schedule. Now, how interleaving of operations can be done here? So for that, here two schedules are given. This is schedule number 1. That means interleaving. That means R1 of x. After the execution of the read of first transaction, you are going to T2 and executing this R2 of z. That means z is reading. After that R1 of z. Again coming back to R1 transaction T1 and doing this read operation. Then R3 of x. That means here this one represents R1 represent transaction 1. R2 represent transaction 2. R1 represent transaction 1, R3 represent transaction 3, etc. etc. And inside here x, z, etc. That is the shared variable that you are going to read or write. Okay. Now we are going to check whether these schedules, here S1 is a schedule and S2 is another schedule given, and whether these schedules are serializable. That means if this is a serializable schedule, you can operate this. If this is not a serializable schedule, then you cannot operate this. That means here you have to, if this is a serializable schedule, then this is equivalent to sub-serial schedule. Okay. So for that, what you are going to do is, now you have three transactions T1, T2 and T3, and now we are going to check whether this schedule 1 is serializable. For that, I am going to have, say, here transaction T1, this is T2 and this is T3. And now I am going to write the execution order. That means R1 of x. Initially you are going to have R1 of x, then R2 of z. That means after that R2 of z, then R1 of z. R1 of z means after that is R1 of z. Then what about R3 of x? After that here R3 of x. That means here this is time order. Time is incremental. That means initially you are going to execute transaction 1, then transaction 2, then transaction 1, then transaction 3. R3 of x, then R3 of y. Here R3 of y. R3 of x, R3 of y, W1 of x. That means W1 of x. W1 of x, W1 of x, W3 of y, W3 of y, R2 of y, R2 of y. That means transaction number 2, R2 of y, then W2 of z, W2 of z and W2 of y. W2 of y. So this is the execution order. This is the serial schedule given. Okay. Now two transactions are said to be conflicting if they belong to two transactions. Then second condition, they are accessing the same variable and one of them should be a write operation. Now we are going to, I am going to have, that means I am going to have a precedence graph. Using this, I am going to draw a precedence graph, and in that precedence graph you have T1 here. T1 is represented by this. You have T2 here, and you have T3 here. T1, T2 and T3 using a precedence graph. Okay. Now Now I am going to compare T1 and T2. T1 and T2, R1 of x. Check whether R2 of x or R2 of x or W2 of x is there. Here you are going to check whether this x is shared among T1 and T2. X is not shared among T1 and T2 because here we don't have any x. That means Z, Y, Z, Y. So x is not shared among transaction T1 and transaction T2. Now we are checking whether R1 of Z. That means this Z is used here. So R1 of Z is here and R2 of Z. The R1 of Z and R2 of Z is not conflicting. Why? Both are read operations. But R1 of Z and W2 of Z, these two are conflicting. Why? They are using the same shared variable and they belong to two transactions and one of them is a write operation. That means only after performing this, that means only after T1 is completed, then you should go to T2. That means here T1 to T2 we have to draw T1 to T2. That means here R1 of Z should be completed before W2 of Z. So you should have T1 to T2 and you have to mark it as Z. Okay. Now what about W1 of x? That means x is not shared among T1 and T2. Then there is no need to compare T1 and T2 again. Now you are going to draw the precedence graph, or you are going to compare the statements of T2 and T3 and check whether there are any serializability, conflicting operations are there. Then R2 of Z. Okay, here the first statement is R2 of Z and here we don't have any Z. Here we don't have any Z. Then R2 of Y. Then here R2 of Y. Then here we have R3 of Y and W3 of Y. That means this R2 of Y and W3 of Y are conflicting. Why? Both are using the same shared variable. These belong to two different operations and one of them is a write operation. So only after completing this 3 you should go to 2. That means from T3 to T2 there is a dependency and we have to mark it as Y. Okay. Now that is Y completed. Then what about Z? Here we don't have any Z. What about W2 of Y and W3 of Y? W2 of Y should be done after W3 of Y, then that means 3 to 2. That means we have already marked it. Okay. Now we are going to compare or whether any operations are there conflicting when we are comparing T1 and T3. That means T1 and T3 x is R1 of x is here, R3 x is here and we don't have any x here. Then R1 of Z is here. Here we don't have any Z, and W1 of x is, what about this W1 of x? Here we have R3 of x. That means here these two are conflicting. W1 of x and R3 of x. They belong to two different transactions. One of them is a write operation and both of them are using the same shared variable x. So you should draw an arrow from 3 to 1 and it should be 3 to 1. 3 to 1 we should draw 3 to 1 and you have to mark it as x. So check whether there are any, whether there is any cycles. Here we don't have cycles because here and here T3 to T1 to T2 and T3 to T2. So this is equivalent to, so here the cycles are, you can have T3. That means you should start from T3 and T3 to T1 to T2 and another one is T3 to T2. This is not valid. So this is equivalent to a serial schedule T3 to T1 to T2. T3 to T1 to T2. Okay. That means if they are given a schedule, then you have to have a table like this. T1, T2 and T3, and you have to, that means in the serial schedule, this is the order. Using that order, using this time order, you have to fill up this, and after that you have to complete this precedence graph. If this precedence graph is having a cycle, then that means this is not serializable. But here in this case we don't have any cycles, so this is a serializable schedule, and the equivalent serial schedule is T3 followed by T1 followed by T2. Now we are going to check whether this is serializable. Second one, S2. I am going to check whether that is serializable. That means R1 of X. Okay. Then R2 of Z. After that R2 of Z. Then R3 of X. R1 of X. R2 of Z. Then R3 of X. This is R3 of X. Okay. Then R1 of Z. R1 of Z. R2 of Y. R2 of Y, R3 of Y, R3 of Y, W1 of X, W1 of X, W2 of Z, W2 of Z, W3 of Y, W3 of Y, and finally W2 of Y, W2 of Y. So this is the order. This is an ordering, depends on the time. And now again we have three transactions T1, T2 and T3. Now I am going to fill up the precedence graph T1, T2 and T3. Okay. Now again T1 and T2 comparing. Here we have X, here we don't have any X. Here we have Z, R1 of Z, and it is conflicting with W2 of Z. So you have to draw an arc from 1 to 2. 1 to 2, and that is Z. Okay. Then what about X? Here we don't have any X. Okay. That is T1 to T2 you have Z. Now comparing this and this, here Z is there, here we don't have any Z. R2 of Y is there, here W3 of Y is there. R2 of Y and after that W3 of Y. So from 2 to 3 you have to draw an arc. From 2 to 3 you have to draw an arc, and these two are conflicting, and R2 to R3, and you have to mark it as Y. Okay. Now what about R2 of Y? We don't have any. Here we have Z, here we don't have any Z. And W2 of Y and W3 of Y, that means this W3 of Y is coming before W2 of Y. So from 3 to 2 you have to have another 3 to 2. That means here 3 to 2 Y. Okay, 3 to 2 Y. Now I am comparing T1 and T3. T1 and T3. That means X. R1 of X. Here we don't have any X. R1 of X and R3 of X are not conflicting. What about R1 of Z? Here we don't have any Z. What about W1 of X? W1 of X and R3 of X are conflicting. So from 3 to 1 you have that means only after executing this you have to go for this. That means from 3 to 2, 3 to 1 you have an arc. From 3 to 1 you have an arc, and that is labeled X. Here, see, here we have cycles T3 to T1 to T2 to T3. T3, T1, T2, T3 you have cycle. Then T3, T2, T3 you have cycles. So as this is having cycles, it is not equivalent to a serial schedule. So this schedule is not serializable. This is serializable. Okay, this is serializable. This is not serializable. This is the way you can check whether a schedule is serializable. Suppose that a question is given, that means you have 2, 3 or 4 transactions and the transaction statements are there. Here this is a read. R stands for read, W stands for write, somebody they say commit operation, if they will give C, and if about test statement it is A. So suppose that we are concentrating only on R and W. Mostly they are giving this R and W, and depending on that, that means these statements, these are the sequence of statements in which you are going to execute, and if this is the sequence, then you are going to check whether it is serializable or not. See, if it is serializable, that means it is equivalent to a serial schedule, and that means that's a valid schedule. If it is not serializable, it is an invalid schedule. Okay, so this is very important checking the serializability of schedules, and you have to go through the algorithm also. Okay, thank you.